Recording in progress.
Hello, how are you? Today we are going to see an example of how to calculate displacement. As you know, displacement is a vector uh, uh, quantity, which means it have distance and direction. So to calculate displacement, we need to know the distance covered, also the directions, so that we know the final displacement between the starting point and the final point of an object. So I have an example here, show you. Yeah, a man walks 10 kilometers to the north and 15 kilometers to the at 50-degree north of west. A man walks 10 kilometers north and 15 kilometers at 50-degree north of west. What is the displacement from the start? I did try to make some of the pictorial presentations of like the motion of this person. So this person moved here. Sorry. Yeah, first the person moved from point A, from here to point B. I'm going to show you how he moved. First he moved north. Forget this one, it's a mistake. So he moved 10 kilometers north, right? Here, through the green line, he moved 10 kilometers north. I might need to delete this one because I don't need it. Yeah. So he moved 10 kilometers north and then 15 kilometers at an angle of 50 north of west. Here, this angle, which is north of west. First he moved 10 kilometers north and then he moved 15 kilometers at an angle of 50-degree north of west. Now the question is, what is the distance, the total displacement between point A and point B? What's the displacement between the starting point of the person and the final point? So we need to calculate this distance. This displacement. How do we do that? First, we need to break down the X and Y components of the displacement, the final displacement. So as you know, there are X and Y axis of a given vector when it's in at an angle. Like now, these 15 kilometers have X axis and Y axis, right? So if we take the 50-degree angle as a reference, then we say this line is adjacent to 50-degree, and this line is opposite to the 50-degree, and this is called hypotenuse from the right angle triangle. Adjacent, opposite, and hypotenuse of the triangle. So now we have the x-axis and also the y-axis. So we are trying to break down so that we can calculate the distance from A to B, right? So what's next? Now we know this 10 kilometer. It's also the distance from this point to here is also 10 kilometers. So the total distance, if we translate, if we move this a-axis toward this point, this leftwise toward this negative x direction, right? The 10 kilometer, this would also become a 10 kilometer, right? North direction. So, and the next is also, we know the adjacent line to the 50-degree angle is also the same as this line, right? The next is this, the red line is the line we are asked to calculate the total displacement between the point A and point B. So what do we do here? Sine of 50-degree, the sine of this angle, is equal to adjacent over hypotenuse. Adjacent over hypotenuse. The hypotenuse is already been given, it's 15 kilometers. So sine is equal to adjacent over hypotenuse. So adjacent is equal to 15 kilometers times sine of 50-degree, right? So adjacent is 15 kilometers times the sine of 50-degree is 0.766, which is approximately 11.5 kilometers. And cosine, the cosine of 50-degree is equal to opposite over hypotenuse, which is 15 kilometers again. So the opposite is opposite is equal to 15 kilometers times cosine of 50, which becomes opposite is equal to, sorry, it's not opposite, it's opposite is equal to 15 kilometers times 0.64, which becomes 9.64 kilometers. Now we know this is 11, adjacent is 11.5, and the opposite is 9.6 kilometers. So the total distance between here and here, this distance, the vertical distance of point B from x-axis. The vertical distance of point B from x-axis is 10 kilometers plus opposite. Opposite is 9.6. So the vertical distance is 19.6 kilometers, right? This distance is 19, total distance here is 19.6 kilometers. Let me show that by symbol. Can make this one like this. This distance is best is 19.6, which is equal to 10 plus 9.6 equal to 19.6 kilometers. This is the total distance here. Okay, this distance. So the total distance from between the x-axis and point B is 19.6 kilometers. And we know adjacent, the adjacent is 11.5 kilometers. So 11.5 kilometers. The adjacent is 11.5 kilometers, right? Now, what do we do? How do we calculate the distance between point A and point B? Remember, this is a right angle triangle. We have been given the two small sides, and we have to look for the hypotenuse, the red one. So if this is A and this is B and this is C, the red axis, the point between A and B, the distance between A and B is the hypotenuse, or C. So A square plus B square is equal to C square. So what do we do? Again, we come here and calculate. I'm going to show you like this. So what is A? A square, 11.5 kilometer square. That is A square, adjacent square. A square A square times B square. B is 19.6 kilometer, again square, is equal to C square. C square is C is the distance between AB and B square. This is using right angle triangle, Pythagoras theorem. I think that's Pythagoras theorem, if I'm not mistaken. Right? A square plus B square is equal to C square for this triangle. For this triangle, A square plus B square is equal to C square. Now, we're looking for the distance between AB, that's the displacement, and we need to calculate the angle. Can easily calculate the angle when we get the hypotenuse. We can also calculate from the tangent. We can get the angle of this here, this angle, the angle between the 11.5 kilometer and the red line, point A and B, can be calculated from the tangent, which is adjacent over opposite. So 11.5 over 19.6 can give us a tangent, and then we can look for the angle for that value of tangent. Or we can still calculate the hypotenuse, then we can go to sine 11.5 over the hypotenuse. Anyways, let's calculate 11.5 times 11.5 and calculate 11.5 times 11.5 gives you 132.25. 132.25. This is equal to 132.25 kilometer square. There is a plus sign, A square plus B square. So we have a plus sign here, a plus sign here. And 90.6 kilometer square is 19.6 times 19.6 equals 384.16. 384.16. $19.6 times 19.6. Yeah, 384.16 kilometer square, which is equal to AB square. AB square. Okay, now what's the value of, okay, 132.25. 132.25, I need to add 132, 132.25 plus 384.16. 384.16 equals 519.41. 519.41. Is equal to 519.41. 519.41 is equal to AB square. AB square, which means AB is equal to the square root of 5, yeah, the square root of 519.41 is 22.79, which is equal to 22.79. Now, we have found the result. The distance between A and B, in terms of distance, is 22.79 kilometers. Now, kilometer. Okay, this is 22.79 kilometers. This is 11, this is 19, and this is 22.79 kilometers. Now we have got the distance. What about the direction? I mean the angle, because it's not displacement. Now we need to add the angle, because this can be east or west, or they are not the same. See, distance in all the directions can be the same, but displacement is not the same. Yeah? So the angle should be calculated. So how can we calculate the angle? Let's divide 11. Let's get from the tangent. So 11.5 divided by 19. Yeah, tangent of this angle here. Let me put this one. This angle. We are calculating the tangent of this angle. So what is the tangent of this angle? Tangent is equal to adjacent over opposite, right? So adjacent is 11.5 kilometer divided by, and this one is 19.6 kilometer. 19.6, opposite is 19.6 kilometer, which is equal to, a kilometer will be cancelled by kilometer, and we have a number 11.5 divided by 19.6, right? 11.5 divided by 19.6 equals 0.586. 0.586 is the tangent of this angle. Now we need to get this from the a table. I'm going to search it online. I'm very sure I can find it. Tangent of tangent value of, what is the value? 0.586. 0.56 is what do you call it? Tangent. What is this thing? What angle? Angle as tangent of 0. Okay. There should be, normally we should get like a a table where you could look for this, but we need to see, maybe I need to just 5.8 tangent 0.5 to 8. Tangent of 0.58 is 33.2. So this is, which is equal to 3.2 degree. Now we know. So how do we say? How do we answer this? The answer for this question, let me move this thing a little bit to the side. Move it a little bit. So the answer is so the answer for the question, if a man moves 10 kilometers to the north and 15 kilometers at an angle of 50 degree north of west, 50 degree north of west, total of 15 kilometers. What's the displacement between point A and point B? The displacement between point A and point B is calculated based on the breakdown of the X and Y axis of the 15 kilometer north of west line. That would give us adjacent and opposite. And we did calculate based on sine, cosine formulas. And we got this distance from A to B, 27, 22.79, would say displacement, total displacement is 22.79 kilometer at an angle of 33.2 degree north of west. That's the answer. This is the answer. I hope that's correct. And let me know if I did anything wrong. This is from my very, very old, very long time physics, grade 11 physics lecture. And I did it for a given purpose. The person who gave me this assignment, you know who you are. So I did it. I tried to solve this problem. So I hope you learn something. And yeah, I love physics. I really like just playing with the numbers. And it's also very meaningful. Like, it's very logical. Like, people usually go like this. You could go even in a very zigzag line or the like. But what's the distance? How far did it go from the starting point? What's the shortest distance? You know, displacement gives you the shortest distance between the starting point and the end point. But the total distance, to get the total distance, we just need to add 10 kilometer plus 15 kilometer, which is 25 kilometer between point A and point B. But the total displacement is a straight line between the initial point and the last point of the path which was covered. Anyways, that's how we calculate displacement. Thank you very much. I hope you get something out of this discussion.